Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic, undiscovered planet is hiding behind Neptune. Volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole U.S. territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lepidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, The atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the Sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the Northern and Southern Lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait, it's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever.
In our solar system, most planets spin counterclockwise, but not Venus. This rebel planet decided to spin clockwise, and scientists are still trying to figure out why. By the way, why do planets rotate in general? What defines the speed of their rotation? Does the Sun rotate? Buckle up and let's try to answer these questions. Venus is the second planet from the Sun and the hottest planet in our solar system. Did you know that Venus is sometimes called Earth's twin? That's because it's similar in size and composition to our own planet. But that's where the similarities end, because Venus is a pretty crazy place, to say the least. For example, the weather. On Venus, it's always hot and cloudy. And when I say hot, I mean it like it's over 800 degrees Fahrenheit there. And those clouds? They're not made of water like the ones on Earth. Instead, they're made of sulfuric acid. So yeah, you wouldn't want to go outside without a really good sunscreen on Venus. If you look at the photos taken from its surface, you can see these toxic yellow clouds and cracked, desolate landscapes. And the spacecraft that captured this turned off almost immediately after sending these photos. Poor fella. But the surface of Venus isn't just some solid, dark, flat land. In fact, Venus has mountains that are taller than Mount Everest. These mountains aren't made of rock like the ones on Earth, though. Instead, they're made of a kind of volcanic material that's denser. Venus is a pretty creepy place that holds many mysteries. One of them has been puzzling scientists for years, and this is the planet's rotation. Most planets in our solar system rotate counterclockwise, but Venus isn't like the other girls. It rotates clockwise, and that's not all. It also rotates around the Sun faster than it rotates around itself. In other words, a year on this planet passes faster than a day. It's almost like Venus made being quirky its life mission. But why is that? Well, scientists have a few theories. The most popular theory says that Venus was actually spinning counterclockwise like the other planets, but then something happened to flip it around. And what could that something be, you ask? A planet-sized object. Yep, astronomers believe that something huge once collided with Venus, causing it to spin in the opposite direction. You can imagine this like a cosmic billiard shot, with this mysterious huge object being the cue ball and Venus being the target ball. But we can't actually say that Venus is spinning the wrong way. There's no such thing as a wrong direction of spin in the universe. This is actually called the retrograde rotation. This is when a planet rotates in the opposite direction to its orbit around the Sun. Venus, for example, has a retrograde rotation, which means that the Sun rises in the west and sets in the east on that planet. So now, when the horoscope says something like Mercury in retrograde, you'll know what it means. Oh, but Venus isn't the only weird one in our solar system. there are definitely some wacky ways that planets can rotate. For example, most planets in our solar system spin around an imaginary line called an axis. This axis is usually straight up and down in relation to the planet's orbit around the Sun. However, some planets like Uranus have a tilted axis, which means it's almost on its side in relation to its orbit. This tilt causes the planet's poles to be nearly in the same place as its orbit. The result? As the planet orbits the Sun, different parts of it receive different amounts of sunlight, causing extreme seasonal variations. For example, one pole might experience continuous sunlight, while the other is in complete darkness for a long time. Uranus is the only planet in our solar system that rotates on its side. Scientists think that it could repeat Venus's history. Once upon a time, a large impact knocked Uranus off its original axis of rotation, causing it to tilt at an angle of 98 degrees. We should be grateful for Jupiter. Its crazy gravity pulls all the asteroids and protects us from such collisions. All this is somewhat similar to tidally locked planets. Imagine going on a date with a planet, but instead of being charming and mysterious like you'd hoped, it's just staring at you with the same face all night long. That's basically what it's like to hang out with a tidally locked planet. Tidally locked planets are planets that rotate around their axis at the same rate that they orbit their star. This means that the same side of the planet always faces the star, while the other side is in permanent darkness. Being tidally locked can have some weird effects on the planet's climate and weather. The side facing the star can become extremely hot, while the other side can be incredibly cold. The atmosphere on the planet can also get pretty wild, with strong winds blowing from the hot side to the cold side. And it doesn't have to be planets only. Our moon also works this way. Did you know that we always see only one side of the moon? That's because it's tidally locked to the Earth.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new Sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the Sun and gets its mass. Now we have 2 suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having 2 centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining X-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our 2-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators.
In space, no one can hear you scream. Or is that, in space, no one can hear ice cream? Well, either way, we know that no supernovas, crashing asteroids, and burning planets make a sound in space. Or do they? What if you actually can hear something out there? Well, let's see. Okie dokie, back to middle school. Sound is a mechanical wave originating from vibration. What exactly does that mean? Well, the simplest example is guitar strings. Let's pluck one of them. It starts to vibrate. The atoms inside the metal string begin to push and beat the atoms of the air around them. So now, atoms are constantly pushing each other until they reach our ears. It's like a wave from a pebble thrown into a pond, and it happens very quickly, at a speed of about 761 miles per hour. Then our eardrums begin to vibrate at the same frequency, and the little bones inside our ears transmit this vibration to the brain. The brain then does its magic, recognizes the pattern, and turns it into sounds. Great! Now we know that we need some particles to create sound, and we can find these particles in gases, liquids, and solid substances. And what about space? Nope, it's almost a perfect vacuum. And you've probably already heard that there's no sound in space because it's a vacuum. But what does it actually mean? Well, a vacuum is a perfect void. It's an area completely devoid of matter. It means there's nothing there. Yeah, despite all those celestial bodies in space, there's actually no air in between them. No atoms, no particles, nothing, nada, zippo. Well, almost. To be honest, the perfect vacuum doesn't really exist. We can't get rid of atoms for good. But space is very close to this notion. On average, there are 15 to 80 atoms per 1 cubic inch. This may sound like a big number, but keep in mind that these atoms are tiny, and the void distance between them is huge. For comparison, 1 cubic inch of air contains about 16,000 atoms. So, of course, with such a low density, these atoms can't push each other. Even if the vibration is very strong, like, I don't know, a supernova, they still won't be able to do that. So, movies have been lying to us. All these epic space scenes actually take place in an awkward silence. Who would have guessed? But don't get upset. What if I tell you there are, in fact, some ways to hear sound in space? First of all, there's still sound on other planets. If there's an atmosphere on a space body, or at least something like gas, water, or a solid surface, there will be sound. In our case, the atmosphere becomes completely silent at about 60 miles above the Earth's surface. That's where the sky stops being blue and a black starry veil begins. In any case, we'd have to land on another planet, or at least get close to its atmosphere to hear something. But whatever it is, it would sound very different. Let's take our favorite Venus as an example. The atmosphere there is very dense. Scientists jokingly call it a thick chemical soup. No thanks. So, if you somehow managed to stay alive and speak there, your voice would be very different. It would become much louder, and it would sound deeper. So, if you want a pleasant baritone, you know what to do. I wonder what would happen if Earth had a denser atmosphere. What would we hear then? Well, you can vaguely imagine that if you've ever been in the water. Water is very dense. Sound moves there much faster and better compared to the air, at a speed of almost a mile per second, depending on the water temperature. So if you sit in an empty room with no sound sources, you won't hear much, right? Now, dip your head in the water and check out how the same silence sounds here. It's not quiet at all. Even if you ignore the ever-present sounds of the water itself, you'll immediately notice how well you can hear your own body, how your blood pulsates in the veins, how your heart works, the slightest movement of your fingers. Kinda creepy, isn't it? This gives us an idea of what would happen to us on a planet with a denser atmosphere. And that's just crazy. We would hear everything. From scurrying animals to the movement of tectonic plates. Ah, come on, you'd probably say. It's obvious that there's sound on other planets. But didn't you say we can hear something in open space? Actually, yes. For example, in a cloud of dust. You can find space dust almost everywhere in space. It may be the remains of a star or something else. And in these places, everything is a bit denser than usual. This means there are probably dust clouds where particles are very close to each other, which means they can produce sounds. Of course, those will be very quiet and transmitted over a very short distance. But it's better than nothing, right? Plus, we already have one real space sound recorded. It came from the Perseus galaxy, which is located 250 million light-years away from us. NASA recorded it in 2003. Those of us music geeks will want to know that it's a B flat, 57 octaves below middle C on the piano. You'd have to add another 660 keys to the left on the keyboard. But its frequency is so low that the human ear unfortunately can't hear it. But besides that, we can only hear something inside spaceships. These are small pockets of air, after all. Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere. There are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for 1 billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable. But now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon, yet many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too.
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds. although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.